Good morning students. In this video you are going to learn about wave particle duality of matter and the quantization of angular momentum and the de Broglie concept. So the first topic, wave particle duality of matter. So the Albert Einstein proposed that light has dual nature. He proposed that light has dual nature. So what is the dual nature it has? It behaves like particle as well as wave. So we can say the light energy is photons. Photon means small packet of energy. So light photons behave both particle as well as wave. Then the Louis de Broglie extended this concept. Louis de Broglie extended in this concept and proposed that all form of matter showed dual character. Louis de Broglie extended this concept and proposed that all form of the matter, any kind of the matter shows the dual characters. So to quantify this relation, he derived an equation for wavelength of matter wave. He derived an equation for wavelength of matter wave. He combined the following two equations of energy of which one represented wave character and other represent a partial character. So wave character equation is h nu. It's a Planck equation. And the particle nature, the equation is Einstein equation, E is equal to mc square. So Planck hypothesis, the first equation is Planck hypothesis. So energy is equal to h nu. So h is the Planck constant, nu is the frequency. Then the second equation, Einstein mass energy relationship, already we know that in lower class itself, E is equal to mc square. E is the energy, m is the mass of the particle, and c is the velocity of the light or velocity of the particle. So combine this equation, Planck quantum hypothesis and Einstein mass energy relationship. So combine these two equations, we have h nu is equal to mc square. H nu is equal to mc square. So here frequency nu is equal to c by lambda. You have to take nu is equal to c by lambda. So instead of nu, we have to substitute c by lambda. So h c by lambda is equal to mc square. Then the equation can be rearranged into, we want to find out the lambda, so wavelength of the light. So lambda is equal to, here c square, so cancelled on c, and rearrange the equation. So lambda is equal to h by mc. So lambda is equal to h by mc. So the equation represented the wavelength of photons whose the momentum is given by mc. The momentum is given by mc. M is the mass of photon and c is the velocity of the photon. So photon have zero rest mass. So for the particle of matter with mass and moving with a velocity v, m is the mass of the particle and v is the moving with the velocity. The equations can be written as, so here lambda is equal to h by mv. This equation is wavelength of photons, this equation is wavelength of particle. So this is valid only when the particle travel at speed much less than speed of light. This is valid only when the particle travel at the speed much less than the speed of light. Okay students, so this equation tells us the moving particle can be considered as wave. A wave can exhibit the properties of particle. So that means the equations implies that it has both the characteristics. It behaves wave as well as particle. So for particle with a higher linear momentum, what is linear momentum? Mass into velocity is called linear momentum. So particle have higher linear momentum. So the wavelength will be so small. The particle have higher linear momentum, that's why the wavelength will be so small and it cannot be observed. For microscopic particle such as electron, the mass is of the order of 10 to the power of minus 31 kilogram. Hence, the wavelength is much larger than the size of atom. It is very important, students. So wavelength is much larger than the size of atom. The electron wavelength, microscopic particle wavelength is always higher than that of the size of atom, wavelength of size of atom. So the wavelength is significant, become significant. The microscopic particle wavelength is become significant. So let us understand this by calculating de Broglie wavelength in the following two cases. So we have to calculate the wavelength for iron ball and electron. So iron ball, the mass is 6.626 kilogram. Its moving velocity is 10 meter per second. In the similar way, electron moving speed is 72.73 meter per second. So the formula is wavelength of iron ball is equal to h by mv. Lambda is equal to h by mv. We have to substitute the values. Okay. So the h is the Planck constant. It is a constant value. Already we know the value 6.626 in 10 to the power of minus 34 kilogram meter square per second is the h value. Then divided by, we have to substitute the m value, mass of the iron ball. So what is the mass of the iron ball? 6.626 kilogram. Then velocity, the moving speed is 10 meter per second. Okay, we substitute all this value, then we have to simplify that. So here we have to cancel out kilogram, here meter square, here meter, so cancel out, so remaining meter, then per second cancel, so remaining we have meter unit. Then we have to simplify that here. So we get the answer 1 into 10 to the power of minus 35 meter. So in the similar way, we have to find out the wavelength of electron. So h by mv. So we have to substitute the value, the same Planck constant value, 6.626 in 10 to the power of minus 34 kilogram meter square per second, divided by mass of electron is 9.11 in 10 to the power of minus 31 kilogram. Then the velocity of electron is 72.73 meter per second. So you have to cancel out kilogram, meter square, here meter you have to cancel out remaining meter, then second, per second you have to cancel out. Then we have to simplify that, we will get 6.626 divided by 662.6. So we have to cancel out 0.001 and 10 to the power of minus 3. Okay, we have to multiply that, we will get 1.10 to the power of minus 5 meter. So the electron wavelength which is higher than that of the iron ball wavelength. So iron ball wavelength is 1 into 10 to the power of minus 35 meter, which is very very small. So the wavelength of electron is 1 into 10 to the power of minus 5 meter, which is higher. So for the electron, de Broglie wavelength is significant because it is higher and measurable, while for the iron ball is too small to measure, hence it become insignificant. Okay students, the electron for the electron, de Broglie wavelength is significant and measurable, while the iron ball wavelength is too small and it become insignificant. So the next concept is quantization of angular momentum and de Broglie concept. So the de Broglie derivation is very very important detailed question. Then the quantization of angular momentum and de Broglie concept also very important question. So according to the de Broglie concept, the electron that revolves around the nucleus exhibit both the particle and the wave. Already we know that according to the de Broglie concept, electron revolve around the nucleus. So electron revolve itself and revolve around the nucleus. It exhibits both characteristics. What are the characteristics? It behaves particle as well as wave character. In order for the electron wave to exist in phase, that means they continuously revolve around the nucleus in a particular orbit. Continuously it revolves. So that is called in phase around the orbitals. So the circumference of the orbit should be an integral multiply of wavelength of electron wave. Okay, so the circumference of the orbit should be integral multiply of wavelength of electron wave. Otherwise the electron wave is out of phase. That means discontinuous, is not allowed. So circumference of orbit is equal to n lambda. N is the number of wave. Okay, lambda is the wavelength. So circumference of the orbit is equal to n lambda. Okay, so what is the formula of circumference of orbital? 2 pi r. 2 pi r is the circumference of the orbital. So 2 pi r is equal to n lambda. So already we know that circumference of the orbital should be an integral multiply of wavelength of electron. So is equal to n h by mv. So lambda value already we know that from the de Broglie derivation we have to substitute that. So instead of lambda, h by mv. So here n into h by mv. N is the number of waves. Then we have to rearrange this equation. So we have to interchange that. So we have to taking the r. So multiplied with mv. So mvr. Then here the replacing the 2 pi multiplied with divided into nh. So nh divided by 2 pi. So the equation is rearranged into mvr is equal to nh divided by 2 pi. So that is angular momentum. So angular momentum is equal to nh divided by 2 pi. Okay, so mvr is the angular momentum. How can you say that this angular momentum? mv is the linear momentum, r is the radius of the orbital. So linear momentum multiplied with radius of orbital, they are called angular momentum. So angular momentum mvr is equal to nh divided by 2 pi. So the above equation was already predicted by Bohr. This equation was already predicted by Bohr. mvr is equal to nh divided by 2 pi. Hence, the de Broglie and de Broglie concept are agreement with each other. This equation is agreement with each other. So this is the wave is out of phase. This wave is not continuous, so not allowed. Since this wave is continuous, so continuously the circumference of the orbit, the electron revolve like a wave in this orbit continuously. So this is allowed. In phase, this is out phase. Here the number of waves is 3. Here the number of waves is 3. So the electron revolve in the form of waves. The 3 waves revolved continuously in that circular orbit. Here 4 waves are revolved around the nucleus. Here number of waves is 5. Here number of waves is 6. So the wave nature of electron is allowed Bohr orbitals. These are the allowed Bohr orbitals. Okay, students. Then the another important question is Davison and Germer experiment. Davison and Germer experiment. So the wave nature of electron was experimentally confirmed by Davison and Germer. Wave nature of electron was experimentally confirmed by Davison and Germer experiment. Okay. So this is the source of electron. So electron source, electron produced by electron gun. So that the electron falls onto the nickel crystal. Okay. So they allowed the accelerated beam of electron fall on the nickel crystal. So the accelerated electrons fall onto the nickel crystal and recorded the diffraction pattern. The diffraction pattern is detected and recorded. Okay. So the resultant diffraction pattern is similar to X-ray diffraction pattern. So this observation. So what is the observation? The diffraction pattern of electron wave is equal to diffraction pattern of X-ray. The finding of the wave nature of electron leads to the development of various experimental techniques. Okay. The finding of wave nature of electron lead to development of various experimental techniques such as electron microscope, low electron diffraction, etc. Okay, students. So Davison and Germer confirmed that electron have wave nature. So what is an experiment? The accelerated beam of electron is fall onto the nickel crystal and observe the diffraction pattern. The diffraction pattern is coincide with X-ray diffraction pattern. So both have wave nature. Then Heisenberg uncertainty principle. So it's very important. 3 more question. Heisenberg uncertainty principle. The dual nature of matter impose a limitation on the simultaneous determination of position and the momentum of microscopic particle. Already we know the dual nature. So what is the dual nature of matter? It have particle character as well as wave character. So this limitation the simultaneous determination of position and momentum of microscopic particle is very difficult. So based on this Heisenberg concept, that is uncertainty. Some uncertainty is shown in microscopic particle. So what is the uncertainty principle? Impossible to accurately determine both the position and the momentum of the microscopic particle simultaneously. We cannot predict at the same time position and the momentum for a microscopic particle. Okay students, this is very important question. So what is the uncertainty principle? Heisenberg uncertainty principle. Impossible to accurately determine both position and the momentum of the microscopic particle simultaneously. So product of uncertainty error in the measurement expressed as follows. What is the equation? De Broglie equation. Heisenberg equation. Delta x into delta p greater than or equal to h by 4 pi. So delta x is the position of the microscopic particle, delta p change in momentum, change in position, and delta p is the change in momentum. So greater than or equal to h by 4 pi, h is the Planck constant. So the uncertainty is determined where delta x and the delta p are uncertainties that determine the position and the momentum respectively. So uncertainty principle has the negligible effect of macroscopic object and becomes significant only for microscopic particles such as electron. Uncertainty principle has a negligible effect for macroscopic object and it becomes significant only microscopic particle such as electron, proton, neutron, like that. So let us understand this by calculating the uncertainty in the velocity of electron in hydrogen atom. So before that we know about the radius of hydrogen, Bohr radius of first orbital. Hydrogen is 0.529 Armstrong. So assuming that the position of electron in the orbit is determined with accuracy of 0.5% of the radius. Okay students, the Bohr radius of first orbit is 0.529 Armstrong and assume that position of electron in the orbit is determined with accuracy is 0.5% of the radius. So uncertainty of position we know that change in position is equal to delta x. So first we have to find out delta x. So what is the accuracy? What is the value? Position 0.5%. Okay, so 0.5%. So percent means we have to divide it with 100. So 0.5 divided by 100 into what is the radius of first orbit? 0.529 Armstrong. Okay, so the Armstrong is equal to 10 to the power of minus 10 meter. So instead of Armstrong we have to substitute the values in meter. So 1 Armstrong is equal to 10 to the power of minus 10 meter. Substitute in this. Then we have to simplify that. 0.5 divided by 100 and multiplied with 0.529 into 10 to the power of minus 10. So we get delta x is equal to 2.645 into 10 to the power of minus 13 meter. From the Heisenberg uncertainty principle, so what is the formula? Delta x into delta p greater than or equal to h by 4 pi. So already we know that momentum. So momentum delta p is equal to mv. So delta p is equal to m delta v. So instead of momentum, we have to substitute that mv. So m delta v. Now we know the position. Now we want to find out the change in velocity. So rearrange this equation. So delta v is greater than or is equal to, rearrange this equation. So delta x is cross multiplied with the 4 pi. So delta x is equal to h pi 4 pi. Delta x and delta m cross multiply with 4 pi. So for h pi 4 pi m into delta x. So rearrange this equation. Then we have to substitute the values. So already we know that h is the constant value. What is the Planck constant value? 6.626 in 10 to the power minus 34 kilogram meter square per second. Then 4 pi value is 3.14. Then the mass of electron is 9.11 in 10 to the power minus 31 kilogram. Then change in position is 2.645 in 10 to the power minus 13 meter. Then we have to simplify that. So we have to cancel out kilogram, meter square, here meter. So we get the unit is meter per second. Then we have to multiply it with this value, then divided with the 6.626 into 10 to the power minus 34, we will get 2.189 into 10 to the power 8 meter per second. So therefore, the uncertainty in the velocity of the electron is comparable with the velocity of light. At this high level of uncertainty, is very difficult to find out exact velocity. Okay students, the uncertainty in the velocity of the electron is comparable with the velocity of the light, is comparable. At a high level of uncertainty, it is very difficult to find out the exact velocity. Thank you students.